Hey everyone, and welcome to This Explainer. I'm absolutely thrilled you're tuning in today because we're about to uncover something super cool. We're going to dive right into the hidden languages that computers use to talk to each other, run your favorite video games, and play those awesome videos.
So I want you to just imagine something for a second. What if your computer, or the tablet you use, or even the phone right in your pocket had its very own secret code hiding right behind the glass screen? You know, a language that no normal person speaks, but one that controls literally everything the machine does? Well, spoiler alert, it actually does.
Okay, let's dive right into this. If you could somehow peel back the screen and peek inside a computer's brain, you definitely wouldn't see English words or sentences. Nope. Instead, you'd see this crazy cascading wall of numbers. It's just ones and zeros repeating over and over again. This massive matrix is the actual true secret language, hiding inside every single machine on the planet.
All right, so let's kick things off with part one, counting like a human.
You see, the math we use every single day is called the decimal number system. Some folks call it base 10. We use the digits 0 through 9. Now, why don't we use base 10? Well, just look at your hands. We humans have 10 fingers to count on, right? So it makes perfect sense for us. But here's the catch. Computers absolutely do not have hands. They don't have 10 fingers, so they need a completely different way to count. Which brings us right to part two, the computer's light switches. Since your computer doesn't have fingers, it has to rely entirely on electricity. And electricity really only has two states. Because of that, the computer uses what's called the binary number system. It's a base 2 system, which means it only ever uses two digits, 0 and 1. This setup perfectly matches all those little electronic circuits inside the machine. To make it super simple, just think of a computer as literally a giant collection of tiny light switches. Imagine pressing a button on your screen. Every single circuit inside your device is just a switch. When electricity is flowing through it, the switch is on, and the computer records a 1. When there is no electricity, the switch is off, and the computer records a 0. And honestly, that is it. 1 is on, 0 is off. So here is the absolutely crucial takeaway. Everything your computer does is just binary at its very lowest level. When you type a single letter on your keyboard, the computer is just translating that into a huge pattern of on and off switches. All your favorite video games, the cool pictures you draw on the screen, even the music you listen to, they're all just millions and millions of these tiny ones and zeros, flashing on and off incredibly fast. It's like a giant puzzle. Now, binary is awesome for the computer because, well, it loves electricity. But for us humans, oh man, it is way, way too long to read. Just imagine trying to write a simple text message to your best friend, but you had to write out millions of ones and zeros. It would be super clunky, super frustrating, and you'd probably make a ton of mistakes. To put that into perspective, just typing the simple word LOL would take 24 ones and zeros. Crazy, right? So that naturally begs a really important question. How do we speed things up? How could early computer scientists and programmers possibly make these giant, endless binary codes shorter and just easier for humans to handle? Well, let's look at part 3, octal, the 8-digit shortcut. The answer is actually pretty genius. They invented secret shortcuts. Programmers quickly realized they needed a much faster way to group all those ones and zeros together. So they created the octal number system. This is a base 8 system that uses the digits 0 through 7. Now, why 8? Because an 8-digit system perfectly groups together the computer's two-switch binary language. It makes it super straightforward to convert. In fact, really early computer systems, like a super famous one called the PDP-8, use this exact shortcut. Let me show you the clever trick behind octal. Take a look at the left side here. You see a group of 3 binary light switches, 110. Well, instead of writing out all 3 of those switches, a programmer can just use one single octal digit to represent the whole group. So 110 simply becomes the number 6. 101 becomes 5. 011 becomes 3. Every single octal digit is basically a magical shortcut that perfectly hides 3 binary switches right inside of it. But we didn't stop there. Moving on to part 4, hexadecimal, the super shortcut. You see, as computers got faster and way smarter, even that octal shortcut wasn't cutting it anymore. The codes were still getting way too long. So they invented the ultimate modern shortcut, hexadecimal. It's an amazing base 16 system, and it squishes binary code down even further. But there was a pretty funny problem when they first invented it.
We humans only have numbers from 0 to 9. To count all the way up to 16, they literally ran out of standard numbers. No way, right? So what did they do? They actually had to start using letters of the alphabet.
Check out this secret decoder ring. This shows exactly how hexadecimal works. It takes 4 whole binary switches and squishes them into just one single character. So the number 9 is 1001. But what happens when we get to 10? Look closely at the table. 10 becomes the letter A, 11 is B, 12 is C, and so on, all the way down to 15, which is represented by the letter F. Basically, these letters are acting in disguise. They're secretly representing bigger numbers.
And you can see right here exactly why hexadecimal is an absolute superpower. Look at that huge, terrifying 16-switch binary number over on the left. 1101, 0110, 10110, 10. I mean, try writing that 10 times without making a single mistake. It's nearly impossible. But by grouping those bits into 4s and using our secret decoder ring, that massive number shrinks down to just 4 simple hexadecimal characters, D6B2. It is quite literally like magic. So here's the big picture. While the computer itself still only ever thinks in those tiny on and off electricity switches, these shortcuts, they are totally for us humans. Hexadecimal and octal allow human programmers to write and read massive amounts of really complex data in a way that's super compact and a whole lot easier to manage. All right, let's do a quick review of our full journey today, code breakers. First, we started with our everyday human math, the decimal system, which uses base 10, just because we happen to have 10 fingers. Then we discovered the computer's true secret language, binary, the base 2 system of simple on and off switches. From there, we learned about the early octal shortcut, which cleverly squishes 3 binary bits into just 1 digit. And finally, we uncovered the ultimate hexadecimal system, which squishes 4 whole bits down using both numbers and the alphabet. Now that you know exactly how computers talk, how they think, and how they use these clever shortcuts, you basically hold the keys to their secret language. The entire digital world is just a giant playground of ones, zeros, and really cool shortcuts just waiting for you to master them. So I'll leave you with this one thought. Knowing how all of these secret codes actually work, what amazing digital creation will you build and code today? Keep learning, keep exploring, and I'll catch you in the next explainer.